Yeah, just feel free to type. Your responses will be anonymous. Don't worry, I won't be able to track after this. Feel free to ask me anything for the this first lecture. So let's see what we have here so far. Okay. Hey. Hello. I am not sure what is this, so I'm not going to read that out. Almost died of a paper cut. No, paper cut won't kill. Okay. Hello. That's my first year, second semester. How can I cope with this module? Do I have to learn to complete this module? Oh yes, of course. This module is very intensive. So during the first 2 weeks, I'm going to give you a very brief overview on what this module will cover and what do you need to do in terms of assignment. Next week, I will launch the assignment sheet and go through with you. Then within these 2 weeks, you will have to decide whether you want to stay in this module or you want to keep this module to some other time, okay? So you decide whether you can cope or not based on my first 2 weeks of lecture and also practical, yeah? Miss, are you married? That's a secret. What's your favorite color? My favorite color is blue color. Let it go. Can't hold it back high. Can I retake the module for fun? Yes, you can retake the module for fun. And if you would like to take the stage away from me for certain topics, feel free to. I'm happy. Okay? Best class in the world. Oh, thank you. Seems like you already know me from somewhere, somehow. Yeah? Okay. So we'll come back to the attendance later on if, let's say, anybody needs it. Can I dinner with you? So, it depends, right? As for this week, my class ends at 7:30, yeah? We don't have any practical. But for next week onwards, I will have 2 more hours of class after this lecture. And every Tuesday to Fridays, I have classes here in Taylor's from 6 p.m. to 10 p.m. Okay? I wouldn't say that that's a dinner anymore. That would be a supper. 100% exhausted. How old are you? That's a secret. Okay? You the best lecturer that I've ever had. Seems like you have already known me. Are you with me last semester? I think so. Pleasant and not noteworthy. If you fail MLPC, you are actually dumb. Not sure who made that remark, but I try to make sure that everyone will pass this module, and I'll tell you how. How old are you? That's a secret. 你好吗？我很好。Hello? Do I need to be good at coding for this module? Which languages? So, do you have to be good at coding for this module? No, you will be good in coding after taking this module. Which languages? Python language only. Hi Oscar, Angry Birds. Thank you for loving me. I love you too, okay? Fail MLPC equals to retardation. Don't make such remark, okay? Yeah, I received an email saying that please behave in the class. BMW or Mercedes, it depends. So MLPC equals to, oh, okay. I'm not sure why you guys make such remark, but it is very, very hard to fail this module, okay? Just make sure that you are with me throughout these 14 weeks and we learn what machine learning is, and we'll get there. We will be spending 3 hours before your final exam on revision. There is no way that you fail this module. Okay? There's no way that you fail this module. Okay. Just, oh, okay. What is that? Okay. So, welcome everyone. So I can see there are still students coming in. Do you actually need the attendance code? So, hello, we have already spent 15 minutes, 10 minutes taking the attendance, and 5 minutes just talking with you, ice breaking with you, okay? Right, so hi, hello again. I'm Nicole. You can call me Miss Nicole or you can call me Miss. So I will be your lecturer as well as tutor throughout this 14 weeks, okay? Stay with me. So for those who are also taking another module, computer vision and natural language processing, you will be seeing me 4 hours per week, right? So there are 2 modules under my care, machine learning and parallel computing, as well as computer vision and natural language processing. So I have a master's degree in data science and business analytics, and currently I'm a part-time lecturer at Taylor's. Okay, so this is the reason why my classes are usually late in the evening. So because of this, I know that it is late. We will always start our class by spending the first 10 minutes taking attendance. So no lectures will be given during that time. So that is a buffer time for everyone to get into this class. So we have 10 minutes buffer, so that make sure you have your dinner or whatever you need before attending the class. Don't faint in the class, okay? So what do I do outside of this lecturing job? So I have a job as a business intelligence analyst at a tech company. So don't ask me where I work. So you will guess it. So in case you will be using one of the apps that our company is developing at some point of time, especially when you look for a job. So that's all I can tell. So why am I working so many jobs in my life, right? So I think what gets me motivated in this mode of working is probably because I really want to nurture the future IT leads or IT champions like you. I love AI and I love BI. So yeah, so that's about me. I teach AI in Taylor's, and then I work BI in companies. So I'm helping companies with data-driven solutions. So far so good. So this is my official email address. If you have anything that you want to arrange with me, feel free to email me. And this is my phone number. In case you want to reach out to me, try using WhatsApp to reach out to me, because I never know that whether I will be working or not, either I'm convenient to pick up your phone call or not. So once you WhatsApp me on your request, then we can decide whether we want to get on a call. Okay? So in this class, those who have already accessing to this slide, you can see that there are three little buttons below here and from your phone. So you can always use these buttons to let me know whether you like the content of the slide, or if you're curious to know a little bit more, feel free to use the cat button. And if you have questions to clarify, please hit on the question mark button so that we can pause and hear your question. Okay? So even if I don't take your question, there will be pauses during the class or throughout the class in order for you to ask your question, usually in the typing format. Yeah? If that is fine. So today, welcome to the very first lecture of MLPC. We are going to do 2 things. We are going to give you a very quick overview of what this machine learning is about, and then we'll talk about what this module offer and expect of you, the expectation of this module. Okay? So let's just get started with what is machine learning. So when we talk about machine learning, it is pretty much related to a field or a buzzword called AI, artificial intelligence. So at a very, very high level, what is AI? So AI is just nothing but a very broad field that aims to create intelligent machines that is capable of mimicking what human is like, especially in solving some problems. Okay, do you prefer the music to be on, or should I turn that off? Okay. So, okay, let's get get back to this slide. We were talking about artificial intelligence. That is a field of a very broad field that aims to create intelligent or smart machine that can think or solve problems like humans. So how do we do that ultimately is using some algorithms. So that is where machine learning sits, where machine learning is a subset of AI that focus on developing algorithms and also statistical models. So when we hear this word algorithm and statistical model, the first thing to think about is mathematics. Yes, we are using mathematics to make machine think or behave like human. Okay, so these mathematical algorithms and also statistical model are essentially the most essential part of machine learning that allows us to make machine learn and also make prediction or decision based on the data that we feed to them. Okay, so then throughout this class we talk about machine learning. So that's about simple algorithm, mathematical algorithms that enables this machine to think and to see data and to behave. So then towards the end of this module, we will also be talking a little bit about deep learning. So deep learning is, again, a very specialized branch of this machine learning. So all it deals with is a lot of neural networks. So a lot of neural networks that essentially allow this machine to think. And how it does that is that the very high-level overview or description of that is it mimics the human brain. Okay, the inspiration comes from the human's brain. We'll talk a little bit more in depth when time comes. Okay, so that's a very big overview of where machine learning sits in the world of AI. So now, when do we need AI? So machine learning is, when do we need machine learning ML? So machine learning is usually needed whenever human is dealing with tasks which are too complex, or maybe it's too difficult for human to code. So in the past, what the human has been able to do is to say like, hey, if somebody click this enter button, do something else. So if you don't click that button, it wouldn't respond to you. So that is not artificial intelligence, or that is not machine learning. Machine learning is, for example, you provide something to the computer or the machine, and it is able to tell you a different thing. Say, for example, ChatGPT today is able to give you a response based on your input. Okay? So that is when we need machine learning. So some task that is so complex and is so impractical, like for example, reading 1 million rows of data in order to decide or to learn what kind of character is a fraud transaction within a set of credit card transactions. So that's impractical. So instead, what we are thinking about is how do we provide this large amount of data into a machine or a computer for it to digest, to read. So then we use some algorithm so that the machine can work it out and explore the data, tells us what is a summary, and then help us to make a decision based on what it has learned from the data which we give to this machine. So let's take a simple example of machine learning. So like for example, how does a music app know whether you may like a certain song or not? So this is a very simple or basic example of machine learning application. So now say for example, we are running a music app. So today, we want to make sure that all our users are engaged with us. They use our app almost every day. So now, how do we ensure that? So one of the idea of ensuring that people stay with our app and stay using our app is making sure that every time we recommend some good songs that the person likes to listen, right? And so how does the machine even know that? So it is impossible for the app company to hire people to understand its user and recommending these songs to the users, right? Every time, every day. That is not so possible. So then how do we do that? what we can do is then the company can then characterize every single song that it has on their app. So say, for example, we are trying to characterize the song using the tempo, the speed, whether the tempo is a relaxed one or is a fast one. Then we can also characterize the song by intensity, whether the song is light or whether the song intensity is soaring. So then we have multiple characters of songs. And then as the users are engaged or using our app, we sort of know that whether this user may like that song or not, because when the user uses the app, they are allowed to like or dislike a particular song. So then we have a certain characteristic of song, we have this user information, and then we also know that whether the person likes this song or not. Say, for example, this person here, we roughly know that this person here likes a song that is with fast tempo and with soaring intensity. And whenever the person listens a relaxed and light song using our app, the person doesn't like the song. So in this case, whenever our app here launches a new song and it is light and relaxed, we do not recommend it to this person because we know that this person wouldn't like it, right? So that is the very basic concept. So now let's say, for example, today, we have 2 new songs on our app. So we have song A, which is fast tempo and also soaring intensity. Another song, song B, medium tempo and also medium intensity. Which song are you going to recommend to this person? Okay, first question. Which song are you going to recommend to this person based on the data that you collect from this person? Song A or song B? So now before we even come to answer this question, so if you are with your phone accessing the slide, so I want you to kind of point where would this song A and song B fall on the graph. So we'll take 10 seconds for everyone to try. Hi. Yeah, so you should be pointing within this canvas only. Don't point here. I know that song A falls here, but I wanted to see where would song A and song B fall on this graph. Okay? Good try. Good try. So this is for me to see whether you have the data sense or not, because taking this module, it requires you to have some data sense. Okay? So I think we are good in that, and if let's say we are not, let's see how we work this out together. So ultimately, the answer that is expected from you is that song A would fall somewhere over here in this graph, and song B would fall under here in this graph. So this graph is the profile of whether this person will like a song or not. Okay, so now in this case, what would you do? What can we do? So if we have this plotted very clearly, this algorithm will be able to help us and to decide on behalf of us to push this song A to this user rather than pushing this song B to the user, to keep this person happy because we are pushing something that he likes to him. Okay? So how does a machine decide whether this person likes that song or not? Ultimately, depends on the data and the character of song that we already know about this person's preferences. Okay? Got it? So that is a very basic example that demonstrates how a machine learning project would look like and how machine is able to think like human. It's all about mathematics. It's all about data. It's about how we quantify certain character about certain object before we feed this data into a machine for it to make a decision for us. So some very official definition of machine learning. We have to talk about this very two pioneer in terms of artificial intelligence. So they are the pioneer in computer gaming. So at that point of time, this person, they are trying to ideate what is the best way to allow this machine to learn. And ultimately, the starting point here is how do they allow this machine to play game with human. So now, the first official definition over here is that machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So which means we don't have to tell the program to respond when a user do something. But instead, how can we teach the machine to respond without being explicitly programmed? So which means instead of line by line, 1 million rows of rules that we give to this machine, how can this machine respond with just one line? So ultimately, that one line refers to the algorithm, which is the models that we are going to learn throughout these 14 weeks. There are multiple algorithms. Some algorithms are based on probability, some algorithms are based on something else. That is something that we will be looking into throughout the 14 weeks. And another very famous definition of machine learning is that it is a computer program that is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. So don't bother about the, I just like how this definition rhymes, but it is not very important for us to get to understanding this fully at this point of time. But we will get the essence of this definition as we progress in the class. Okay, that is the definition of machine learning. So in very simple word, what is learning? Simply put, learning is like right now, we are learning human, you are learning from me, from what I impart on you. So learning is just a process of acquiring a certain knowledge or skills through multiple ways. For example, we can study to acquire a knowledge or skill. We can learn from experience. And we can also acquire some knowledge or skill by being taught, like what you are doing now. So now this is ultimately how human as well as how machine learn. So then, again, in simple terms, what is machine learning? Machine learning is just a science of making computer learn and act like humans by feeding data and information without being explicitly programmed. Okay. So just now we mentioned that there are 3 ways of learning, and in machine learning, there are also 3 ways of learning. So the machine is able to study a big set of data, which you channel to it, and it provides you some knowledge that it has learned. So that is ultimately unsupervised learning. So what is supervised learning? So in the example that we just mentioned earlier, where we already know that, okay, this user like a certain song, this person don't like a certain song. That means we already have a previous experience of knowing whether this person will like certain characteristic or don't like the certain characteristic. That means everything is already labeled, like, don't like, don't like. So whenever we are facing this kind of data, that means it is with a labeled data, the way of how this machine can learn is called supervised learning. And then in case the machine can also be taught to make a decision better, to make better decision. So that area of machine learning is called reinforcement learning. So in the following slide, we'll just quickly go through what these 3 types of machine learning is about. So supervised learning. Supervised learning, it is a method that is used to enable machine to classify or to predict objects problems based on labeled data that is being fed to it. So let's take a very simple example. So say now, for example, your friend give you 3 coins. So first coin is rupee coin, second coin is euro, and then the 4th coin is dirham. So now, each coin has different weight. We know that a rupee is about 3 grams, euro is about 7 grams, and the dirham is about 4 grams. So now, with this information that we have, we already know what this gram is relevant to a certain type of coin. So here, the weight of this coin can become our characters, or it can become our features that we want to teach the machine. The currency then is something which we want to predict. So the currency will be considered as a label. So say now, for example, you just take a random coin, you blindfold yourself, and then you roughly know that, oh, this coin is 3 grams. And we want to be able to tell that, oh, hey, this is actually a rupee, right? So this, because we already pre-programmed ourselves that, okay, if let's say it is a light coin, 3 grams, that's a rupee. So that is also how a machine would learn. It is using the same way as how human learns. So to sum up what supervised learning is that we take a set of known knowledge, then we feed it to the computer algorithm machines with labeled data. We say that 3 grams equals to coin A, 7 grams equals to coin B, things like that. So now, whenever the machine receives a foreign coin, it would tell us or predict what kind of coin it is. So that is called supervised learning. We are feeding the machine with a set of character and a set of labels. And then it will be able to predict based on what it has learned from our data. That is supervised learning. So now what is supervised learning? It is very similar to what supervised learning is, just that right now you have a set of data without any labels. So now say, for example, you just have a list of names of cricket players. So now you have the characteristic of saying what is their scores and whether they have a wickets. So now you just feed it to the machine and ask the machine to figure out who they are, what kind of role he plays, right? And this machine is able to classify, okay, roughly this player 1, 3, 5, 6 is probably one type of player, and another set of player who scores less or whatsoever, they could be another type of player. So without telling the machine what type of player they are, we just tell them that these are the characteristics. Help me figure out what kind of player they are. And the machine will be able to tell us what kind of player they are. So this is a field of machine learning called unsupervised learning. The data that we channel to this computer or machine does not have any labels, okay? Does not have any knowledge. It's just some characters without knowledge. And we ask the machine to figure out for us what it is about. Okay, so then reinforcement learning is another type of machine learning where the agent will learn to behave in an environment by performing actions and seeing the results. So now say, for example, how does this work? So you just randomly take, say we just randomly take a dog and channel to this machine. And for the first time, the machine tells us that it is a cat. So now what we do is we tell the machine that, hey, you make a wrong guess. It is not a cat. Then you tell the machine. So the machine remembers. And the next time it sees another dog, it will be able to not tell you that it is a cat. Instead, it tries to tell you another answer, which is probably dog. So this time it's correct. Then we tell the machine, oh, you have done something right. So in this manner, the machine is learning through some penalization mechanisms. That is reinforcement learning. Okay? So now, in a nutshell, machine learning model, what is machine learning? So machine learning is about how we take a set of input, large set of data, characterized and structured in mathematical format, in numbers. And then we feed it to this machine to figure out and gives us an outcome. And this outcome ultimately is a decision that we want this machine to make on behalf of us in our daily lives when things get a bit crazy, right? So that is in a nutshell what machine learning is. So far, do you have any question? Yeah? Is there anyone typing? 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You want dessert? Maybe after class? Okay, so now that's a quick overview on what machine learning is. And right now, in another 15 minutes, we are going to go through some of the very boring stuff, like the module information. Things which are boring, but you need to know, okay? So this course is offered as a primary major, and it is a core module. There are officially no prerequisites, but in order to make your life a bit easier, it would be good if, let's say, you have already taken some of these modules, like, for example, data structures and algorithm, so that you understand what a structured data is. It would also be preferable that you already know what big data technology is. So when it comes to parallel computing, how do we parallelize tasks? It is easy for you to capture the information. And data analytics and machine learning is ultimately one of the entry to this, machine learning and parallel computing, to have a more in-depth thing. I hope that you guys have done at least some of this. So before we move on, can I understand a little bit of you more? Like, as in, which program are you from? Is there anyone in the program that is not listed here? So we have Bachelor of Computer Science, BCS. We have BIT. We have BSE. And we have BRDD. So knowing which program you are from will help me to prepare for some use cases that may be of your interest in the future. So I think we see that most of us are from BCS, so not too much of an issue. So those from BRDD, in case you have a very special thing that you want to learn from me, do feel free to reach out to me and let me know, okay? Then we can cover that. So Python will be one of the very main language that we will use throughout the practical in the coming 13 weeks. So let me know how good are you or how comfortable are you with Python, so that I can decide what pace is suitable for you during the practical class. Okay? I don't want to see anyone struggle. Yes, learning is a process, but we'll try to make it pleasant, so make it pleasant for you. Limited exposure, so we'll take it slow. Those who are already Python expert, let me know if you want something more during the practical, yeah? And have you done any of the module which I mentioned earlier? Good. So you understand data structures, and you know what is a structured data, and you know what's an unstructured data, for you to choose the right data set for your assignments, yeah? Cool. Data structures and algorithm. Those who have already done data analytics and machine learning, feel free if you want to take the stage away from me for certain projects, topics, okay? Right, module profile. What is this module about? So this module aims to give you a very broad introduction on machine learning and also parallel computing. We give you the breadth instead of depth, so that to prepare you for future work, you know a lot of them, not necessarily very expert in them, but you must know some of them. So that will prepare you also in case you want to further your studies in a research field, okay? And so another purpose of this module is also to allow you to gain some practice by implementing some of these machine learning algorithms to solve some real-world cases, especially on business cases, because we know that you are going to work somewhere and helping people to solve problems someday, right? And it is a problem-based learning. Problem here doesn't mean like problem as in problem, but use cases, real-world use cases, problem-based learning, okay? 4 objectives from this module: fundamental understanding of machine learning and algorithm. How do we optimize some of the algorithm? Those who have already taken DAML, then this course is really for you to learn about how to optimize and how do you fine-tune certain algorithm. in some part of the pipeline. So for those who have not taken w1ml, then we'll just be learning everything from the basics, learning how to apply the algorithm, then how to optimize and fine-tune them. Okay? Then we want to introduce the integration of disciplines between machine learning and parallel computing. Then we want to allow you to have some hands-on skill development. Ultimately, this is referring to very heavy assignments ahead. And also for you to stay current with the current industry trends. So those will come towards the end of this module. Delivery methods. So there are 4 credits in this module. So every week we will have face-to-face lecture, 1 time, 1 hour per week, practical, 1 time, 1 hour per week. So how are we spending that 1 hour in the lecture and also practical? So as I mentioned earlier, we'll spend 10 minutes of the first 10 minutes taking attendance, 40 to 45 minutes walking you through some core concepts, and then we'll spend the last 5 to 10 minutes for some Q&A. Then for practical classes, we'll also follow the same time allocation where we will be spending the first 10 minutes taking attendance, because we know that I have back-to-back classes, so a 10-minute buffer is just good. It's just nice, okay? 40 to 45 minutes practicing. It's more about you practicing, and I will be there guiding you. Then the last 5 to 10 minutes, Q&A. So try to not drag, because, yes, I mentioned many times, I have back-to-back classes, okay? Then in case you want to have any discussion with me on how do you work on your assignments, how you want me to clarify certain topics, then feel free to use my consultation hour for that. So I'm allocating every Monday from 8 p.m. to 10 p.m. to have this consultation hour. So in case you feel like you have a very long discussion with me, just feel free to block my time to book that time, okay? So the consultation hour is available online. So I have provided the Microsoft Teams link on my times. So feel free to use that and link it to that Microsoft Teams channel to talk to me in case you want to talk. Okay? So learning outcome, at the end of the day, what are we expecting? What are you getting out of this class? So you will be a professional that's able to solve some real-world problem related to data and making decision, not any other real-world problem, okay? And you will be able to design and develop solutions using machine learning algorithm, nothing out of machine learning, and parallel computing applications. And also demonstrate skills in solving practical problems using machine learning and parallel computing. Okay, all good? These are the topics that we are going to cover throughout these 14 weeks. So first week here, we are doing module introduction. Then week 2 onwards, we will be doing further introduction to machine learning. Then we will release your coursework, as well as I will tell you the expectation and the marking rubrics. So then by next week, you will decide whether you want to stay in this class right now or you want to take this class sometime later in your within your tenure with Taylor's. So then we see that we will be spending a lot of time talking about machine learning models. So ultimately, we'll be talking 1 model each week. That's what we plan. So every time we talk about 1 machine learning model, we will also practice them. And we will see what is the difference between different machine learning algorithms and what kind of decision is it doing. Okay? And then finally, we will have a few sessions to talk about this parallel computing for how do we use it for machine learning. Then a little bit on data ethics. Then finally, the last few weeks we'll spend on helping you to revise what are the important topics for your final exam. So we'll spend 3 hours. There's no way that anyone fail this subject, okay? Past year paper discussion, then we'll do module revision during week 14 lectures, then we'll do module revision during the practical, right? No way to fail. So what support is available to you? As I mentioned, Microsoft Teams consultation hour every Monday, 8 to 10 p.m. So you can also reach out to me through WhatsApp. So refer to my times for this code, I would like you to join this group, as in it will help me to communicate last-minute changes of classes in case I have anything ad hoc that I couldn't make it to the class. So in terms of study, if you find it difficult to follow, Taylor's also offers this program called PALS. Ultimately, it is to have a peer assigned to you through student advisory. I haven't actually arranged this before, but in case you feel like you need this service, let me know, and I'll try to figure out the arrangement. Okay? So then, very important thing, how will you be assessed for this module? So you see these pins. So you will be assessed on 3 coursework, 60% of coursework, and 1 final examination, which gives you 40%. So task 1, individual assignment, that will give you 20%, and the release date will be week 2. So the due date will be week 11. So the total marks for this task is 100%. Then task 2 is by week 5, we are going to have this midterm test, and that gives you 10% of your coursework. Then week 7, we will be releasing group assignment. Then the due date is week 13. So I'm thinking to combine this group assignment with this individual assignment to make it easier for you, because I do receive some feedback that the assignments for this module is a little bit too heavy. I'm still pending for approval, so we'll keep you posted. Okay? And finally, 40% of final exam on week 16. So what are some of the achievement requirements for this module? So it depends on how well you do in your coursework and also how well you do in final exam. So ultimately, what you need to make sure is to achieve at least 50% of marks for the overall assessment, and a final grade of C is the minimum requirement to pass this module. So there are a lot which I have written down that is given to me from the school. So feel free to read, and in case you have any question, do reach out to me. So this is a quick summary on what kind of score should you achieve to pass or fail, and what kind of situation will you face in case you fail or in case you are not able to pass a certain element from this class. So there are 3 kinds of situations here. So 4 kinds of situations. So in case you achieve an overall of 50% by passing both coursework and also final exam, you will be able to pass this module. Then in case you pass your final exam, but you happen to just miss one of the coursework assessment, and that wouldn't allow you to pass, so then you will be required to resit for the coursework. Okay? So that is another situation. And in the case where you ace your coursework, but you couldn't turn up at final exam for certain reason, or you are just too panicked and you didn't do well in the final exam, then it will lead you to another situation where you will be required to resit only for the final exam. And if you don't manage to pass both of them, then you have to repeat both of these elements, ultimately repeating the module. Okay? A summary, we have just touched base on the module information, and very importantly, how you are assessed and how can you pass this module. What is the achievement requirement for this module? So, any questions so far? Yeah? Oh, hi. Question? No question? So if let's say there's no question, what's next for us? Next week we are going to have a topic called Introduction to Machine Learning and its Applications. Then we'll release coursework. It is very, very important. Please feel free to be there next week to hear the coursework debrief and also expectation. Okay? So that's a wrap for today. Thank you for attending this class, and I'll see you next week.